An interstellar encounter, the unlikely opportunity of 3I Atlas. Sometimes the universe surprises us with extraordinary coincidences. Right now, one of those moments is happening. The interstellar object 3I Atlas is approaching the Sun, forming a massive ion tail. And by pure chance, two space missions, Hera and Europa Clipper, are moving straight through the direction of that tail. This wasn't planned, but if everything aligns, humanity might collect direct data from the tail of an interstellar comet for the very first time. 3I Atlas, a visitor from beyond the stars. 3I Atlas is only the third known interstellar object. Like its predecessors, Oumuamua and Borisov, it came from another star system, drifting into our own. Now, it's nearing its perihelion, the closest point to the Sun. As it heats up, frozen gases on its surface begin to sublimate, releasing streams of ions that are carried away by the solar wind. The result? A glowing, spiraling tail stretching millions of kilometers into space. An unexpected alignment. At the same time, two spacecraft are traveling along their own missions. Hera, en route to the Didymos-Dimorphos double asteroid system. Europa Clipper, heading toward Jupiter's icy moon, Europa. Here's the remarkable twist. Both missions' trajectories will take them through the extended region of 3I Atlas's ion tail. Scientists used a modeling tool called Tail Catcher to simulate this event. It combines parameters like solar wind direction and velocity to predict how the ions spread through space. The models show both spacecraft passing about 8 million kilometers from the tail's central axis, not close enough to touch the nucleus, but possibly within reach of scattered ion particles. Hera or Europa Clipper. Hera doesn't carry instruments to measure plasma or magnetic fields, so its role would mainly be to refine the geometry of the encounter. But Europa Clipper is equipped differently. It carries a magnetometer and plasma detectors designed to study Europa's magnetic environment. Yet these same instruments might now detect signals from 3I Atlas's ion tail. If activated at the right moment, Europa Clipper could perform the first ever direct plasma measurements from an interstellar object. Scientific objectives. From this encounter, scientists hope to gather three key types of data: ion and plasma measurements, density, distribution, and energy of particles, magnetic structure, how the solar wind interacts with the tail, comparative analysis, differences between interstellar and solar system comets. Such data would also serve as a real-world test for the tail catcher model. If confirmed, it could help predict the behavior of future interstellar visitors with far greater precision. Challenges and uncertainties. Of course, this won't be easy. The spacecraft will pass far from the comet's nucleus, where ion density is extremely low. And as the solar wind shifts, the tail's orientation could change unpredictably. Worse still, neither mission was designed for this. Time and resources are limited. But in science, no signal is still a result. Even a null detection would establish a valuable sensitivity threshold for future missions. Why it matters. If this encounter succeeds, humanity will obtain the first direct measurements from the environment of an interstellar object, a historic milestone. This could reveal how interstellar bodies interact with the solar wind, clues about their origin and composition, and insights into how planetary systems form. It also demonstrates the power of flexibility in mission design. Even unplanned opportunities can lead to groundbreaking discoveries. A step toward the future. The European Space Agency's upcoming Comet Interceptor mission aims to intercept such interstellar visitors directly. Any data Europa Clipper collects from 3I Atlas could inform how these future missions are designed, from sensor sensitivity to flyby trajectory planning. Time is short, but the opportunity is immense. This brief cosmic window might redefine the future of interstellar science. In the end, this is a cosmic coincidence born of pure chance. But if Europa Clipper turns its gaze at just the right moment, humanity may finally touch the tail of an interstellar comet. And in that fleeting moment, we might begin to truly understand what stories the dust from other stars has to tell.
For the first time, humanity may reach across the void and touch the tail of a comet born beyond our sun.